A fixed submission cutoff defines a clear boundary in the procurement process. Review capacity remains uneven, but the rule does not adjust for that imbalance. The system therefore creates a positional difference between submissions received earlier and those received later. Once priority review becomes the effective reward, timing begins to carry economic weight. A proposal submitted earlier enters a less congested queue, increasing its chance of being processed before saturation. Late submission, by contrast, carries a non-recoverable delay that cannot be offset after the cutoff. Sellers respond by shifting effort forward in time rather than evenly distributing preparation. Instead of optimizing proposal quality over the full window, they optimize entry position relative to others. The decision space reorganizes around timing rather than content. This shift appears to improve efficiency at first. Earlier submissions should allow smoother processing and better distribution of workload. The visible signals suggest that the system is absorbing demand earlier without stress. But this interpretation assumes that early submission remains a minority behavior. Once sellers recognize the positional advantage, early entry becomes a dominant strategy. The distribution of submissions begins to compress toward the front of the window. Queue formation no longer reflects random arrival. It becomes the result of synchronized anticipation around the cutoff boundary. Processing load concentrates earlier than the system was designed to handle. As more sellers front-load, the early queue begins to resemble the original end-of-window congestion. The advantage of early submission erodes as the queue saturates sooner. What was initially a timing edge becomes a crowded entry point. At this stage, the cutoff no longer functions as the primary constraint. The effective constraint shifts to the invisible queue position before saturation. Actors begin to compete for placement within a moving boundary rather than a fixed deadline. The system now exhibits a coordination breakdown. Each seller attempts to move earlier, but the collective movement cancels out individual advantage. The queue fills earlier without reducing total congestion. This creates a measurable distortion in processing dynamics. Idle capacity later in the window coexists with overload earlier in the cycle. The system no longer aligns workload with available review resources. The signal of early submission starts diverging from its original meaning. It no longer indicates preparedness, but reflects defensive positioning against queue saturation. Behavior shifts from proactive efficiency to reactive avoidance. At this point, submitting early is no longer optional. It becomes a necessary condition to avoid being trapped in a saturated queue. The incentive transforms from reward-seeking to loss avoidance. The cost structure tightens around timing. Submitting late guarantees delay regardless of proposal quality. Submitting early only maintains parity with others who follow the same strategy. The system locks into a new behavioral baseline. All participants cluster their submissions near the earliest feasible point. Temporal spacing disappears as a strategic variable. This equilibrium stabilizes despite its inefficiency. No individual actor can revert to later submission without incurring disadvantage. The system sustains front-loaded congestion even when it reduces overall processing efficiency. The original rule intended to organize submission flow. Instead, it reorganizes competition around queue position. The cutoff becomes a trigger for anticipatory behavior rather than a neutral endpoint. What appears as improved responsiveness masks a deeper structural shift. The system is no longer processing work as it arrives. It is processing the outcome of synchronized strategic timing. In this configuration, the review queue becomes the true battlefield. The formal deadline remains visible, but the effective competition happens before it. The system operates under a cutoff-driven delay equilibrium. As front-loading stabilizes, preparation timelines compress across all sellers. Work that was previously distributed over the full submission window is now concentrated into an earlier, narrower interval. This temporal compression increases the likelihood of incomplete or rushed proposal assembly. That compression feeds back into the queue itself. Earlier submissions are no longer uniformly higher quality, yet they retain positional priority in review. The system begins processing a higher volume of front-loaded but less stabilized submissions. Review capacity remains fixed while input volatility increases. Evaluators must process more submissions in less predictable states of readiness. Processing variability rises, further destabilizing throughput in the early queue. This introduces a time horizon mismatch within the system. Sellers optimize for immediate queue entry, while the system is structured for steady evaluation across the full window. Short-term positioning overrides long-term processing alignment. The mismatch propagates into submission timing strategies. Submitting slightly earlier than competitors becomes insufficient once clustering intensifies. Actors are pushed toward even earlier preparation cycles to maintain relative position. This escalation shifts the effective start of competition backward in time. Preparation begins well before the formal submission window becomes relevant. The operational boundary of the system extends beyond its defined time frame. As a result, the visible submission window loses its coordinating function. The actual competitive phase now occurs in a pre-window period where timing is less observable. Information about cue saturation becomes indirect and unevenly distributed. Information asymmetry begins to shape behavior within the same actor group. Some sellers infer earlier saturation based on prior cycles and adjust accordingly. Others react later, entering an already congested queue without clear visibility. This asymmetry reinforces front-loading rather than correcting it. Actors with earlier inference push the queue forward even more aggressively. Late reacting participants face increasingly compressed and disadvantageous entry conditions. The queue itself becomes a lagging signal rather than a real-time indicator. By the time congestion is observable, the positional advantage has already been captured. Decision-making shifts toward anticipation rather than observation. This anticipatory behavior amplifies clustering across cycles. Each iteration reinforces the expectation that an earlier submission is required. The system accumulates a persistent bias toward premature entry. Processing imbalance deepens as early congestion intensifies. Reviewers face peak load earlier, while later capacity remains underutilized. Throughput inefficiency becomes structurally embedded rather than episodic. At this stage, timing ceases to be a flexible variable. It becomes a rigid constraint imposed by collective adaptation. All actors converge on the earliest feasible submission point, regardless of individual readiness. The system now operates with reduced tolerance for deviation. Any seller attempting to delay submission for refinement risks falling into saturated delay conditions. Flexibility in preparation is replaced by synchronization pressure. This creates a reinforcing feedback loop between queue saturation and submission timing. Earlier congestion drives earlier submissions, which in turn advance congestion further. The loop stabilizes without resolving the underlying imbalance. However, the precise boundary of optimal submission remains uncertain. Actors cannot perfectly observe where the queue will saturate in each cycle. This uncertainty sustains continuous pressure toward earlier positioning without clear equilibrium precision. Despite that uncertainty, behavior does not diversify. The cost of misjudging timing is asymmetric and non-recoverable. Actors continue converging toward early submission even when the exact advantage is unclear. Over time, the system internalizes this behavior as its default state. Submission timing becomes detached from readiness and anchored to defensive positioning. The queue operates as a preemptive congestion mechanism rather than a neutral processing flow. The visible structure of the system remains unchanged. The submission window still appears evenly distributed and rule-based, but the underlying dynamics are governed by a self-reinforcing front-loading loop that sustains cutoff-driven delay equilibrium. In this stabilized state, the system no longer rewards balanced preparation across the submission window. It rewards the ability to reach the earliest viable submission point before queue saturation begins. Timing advantage becomes the primary determinant of processing position. The system correspondingly stops recognizing refinement time as a meaningful input. Additional preparation that delays submission carries no compensating benefit once early congestion forms. What is ignored is not effort, but any effort that does not advance queue position. At the same time, delay is no longer a neutral choice. Submitting later reliably places entries into a saturated queue where processing delay cannot be recovered. The penalty is embedded directly in timing rather than in a valuation outcome. Under these conditions, sellers no longer choose when to submit based on readiness. They converge on the earliest feasible moment that protects them from non-recoverable delay. The range of viable strategies narrows to early entry as a defensive baseline. The system therefore settles into a cutoff-driven delay equilibrium. The formal deadline remains fixed, but behavior organizes around avoiding the queue that forms before it. What changes is not the rule itself, but the incentives that determine how that rule is used.